Okay, so your first clue is that if cosine is negative and sine is positive, then you have to think, what quadrant will we be in?
2.
Yeah, it would have to be quadrant 2 for that to happen. So it's a quadrant 2 angle. It tells me that the hypotenuse has length 9 and the adjacent negative 2. So that means, let's see here, 81 minus 4, so 77's root. That will give me the angle in the corner there. So if I wanted to find the sine and tangent ratios, the sine of theta is going to be opposite, so root 77 over 9, and the tangent is going to be the opposite over adjacent. What quadrant will we be in if the secant is negative and the tangent is negative? Which one is secant connected to again? Cosine. So if you know cosine is going to be negative as well, which, yeah, so it could be quadrants 2 and 3, but then tangent has to be negative, so it must be quadrant 2. Okay, so this is another quadrant 2 angle. It says here secant, this is the hypotenuse over the adjacent. So this is going to be 7, and this is going to be negative 2. So this would be 45 square root. So I can find the rest of the ratios. Cosine's easy. Cosine is just going to be flipped, so it's going to be negative 2 over 7. The sine is going to be root 45 over 7, and the tangent is going to be opposite over adjacent. So root 45 over negative 2. Yes, Kathy?
If we were, for instance, do the cotangent, should we square everything so there's no denominator?
Oh yeah, so Kathy's asking about rationalizing the denominator. I'm not going to ask you to do that unless the provincial exam specifically said. It's not wrong. You might as well go to the extra step if you feel like it makes you feel better about your answer. But as far as I'm concerned, I'm not testing you on your algebra skills here. I'm trying to test you on your knowledge of trig. So that's an algebra skill to rationalize the denominator. So for me, you wouldn't lose any marks. Provincial exam, if you're worried, then just take the extra time to rationalize the denominator. Okay? Okay, so again, this time we'll take a look if you have a couple of points. You know what? Let's just do one of these points. They're very similar in idea. So let's just do the first point here. Find me the first three, I shouldn't say first three, but find me the sine, cosine, and tangent ratios for that point. Right, 5 and 9 is 14, so yeah, should be root 14, I think. Okay, so then I can find the sine is going to be equal to opposite over adjacent. The cosine is going to be adjacent over hypotenuse, and the tangent going to be opposite over adjacent. Whoops, I messed that one up. Which one did I mess up here? The sine, okay. Bound to happen sooner or later. So this is, which one did I? Sine, okay, so sine is the opposite over the adjacent. And that looks better. Opposite over hypotenuse. So I wrote it right and I said it wrong. Is that okay? You have to bear with me, right? My sleep is in very small quantities at the moment, so. Yeah, it doesn't. That my daughter doesn't seem to realize that, but she just keeps me up all the time.
Yeah, I forgot to ask you, how does it feel being a father now?
It's good. Yeah, it always was good. Okay. So if there's one thing that we really got to get a good hold on, something really important, is exact values. Okay, it uses a lot of stuff we've already done, but we're going to use this from now till the end of trig. So trig is 25% of math 12, and this is probably like, I don't know, half of the questions would involve something in this. So it's pretty important. Okay, so the first thing that we need to pay attention to here, I'm going to show you how to produce some special triangles. Okay, so these two triangles are going to make up our exact values. I'm going to show you how to reproduce them because ultimately you'll need to do this. Okay, so the first triangle you need to produce, I call it the isosceles length 1. So here, whoops, wrong one. So the isosceles triangle, and the sides have length 1. So if you can remember that much, we can get the rest on our own. So for example, how long is the hypotenuse? Yeah, root 2. What's the size of those two angles there?
45.
Yeah, 45 degrees. So equal sides are opposite equal angles. So basically, if you can remember that it's isosceles length 1, then you'll be able to produce that triangle. Okay. Now, the next one is the equilateral length 2. So here's 2, 2, and then this would also be length 2. So this is where it comes from, and if we did this, we'd have some problems because first of all, it's not a right triangle, so there'd be some difficulty. And second of all, the angle is 60 degrees in each of these corners, so we'd only have one other angle. Okay? So what we do is we cut this triangle in half. So that's why you see a dashed line here. This isn't actually part of the triangle. Okay? So the triangle itself, if we chop it in half, okay, then we had 60 degrees here. This will be 90. Let's see if we can figure out what the other pieces would be. Okay. So 30 is the other angle in the top corner, yes. So you could either say to yourself 60 and 90 plus something equals 180, or because we've chopped it in half right here, chop it in half, you end up with half of the 60 or 30 degrees. Okay, what about the lengths? Can anybody give me one of the lengths on this triangle? Sure, Andy.
Base of 1.
Yeah, the base here is 1. How'd you know that? Yeah, we just chopped it right in half. So it used to be 2, now it's 1. Okay, what about the final leg of the triangle? Sure, Alan.
Root 3.
Yeah, root 3. So 4 minus 1 square root 3. Okay, so that's the way you should try to remember generating the special triangles. While you're getting used to it, I suggest that you start your homework by drawing the special triangles so you can keep referring to them in your homework. If this was a quiz or a test, you might want to flip it over and write it down just so you have it there as a reference. Okay, until you get really used to using them. So we're going to use these values now and try and come up with exact values for these angles. So for example, at 30, if I wanted to know the sine of 30 degrees, it's going to be the opposite side divided by the hypotenuse, so it would be 1/2. Okay. If I wanted to know the cosine of 30 degrees, it would be the adjacent side divided by the hypotenuse, so it would be root 3 over 2. And finally, if I want to know the tangent, well, it's the opposite over the adjacent, so it would be 1 over root 3. So the triangles help me reproduce the exact values that you need to know for your course. So what I'm going to have you do now is see if you can fill in 45 and 60 using your special triangles. Okay, so if we do double check, 45 degrees means I'm going to be looking at this triangle here. So you should have 1 over root 2, 1 over root 2, and 1. For 60 degrees, I'm looking at this spot right here, and that's going to be root 3 over 2 for sine. 1 over 2 for cosine, and root 3 for tangent. So for 0 and 90 degrees, I've only given you one other strategy. What's the other strategy we've been able to solve for exact values so far? Unit circle. Okay, so let's take a look on the unit circle at 0 and 90 degrees and see what we can come up with. Okay, so here's 90 degrees, here's 0 degrees, so let's label them. Because then I can use those coordinates to figure out their exact values. So at 0 degrees, the sine is going to be worth 0. It's the y-coordinate right here. The cosine is the x-coordinate at 0 degrees, so it is 1. The tangent is sine divided by cosine, or y divided by x, so we get a 0. Okay. Now, if we're going to do 90 degrees, we're going to look up at these coordinates. Okay. Sine being y, cosine being x. So the tangent here, we would call this undefined. Okay, so what we're going to do now is we're going to try looking at how we apply this, these exact values. So for the first thing, what we're going to do is this angle 3 pi over 4. Okay. So the questions are still the same that we've been asking since we started this part of trig. Okay, so first of all, what's the quadrant for 3 pi over 4? Yeah, it's quadrant 2. Okay. What's the reference angle for 3 pi over 4? Yeah, pi over 4. So now what we can ask ourselves is, okay, pi over 4 is the reference. What will the sine of pi over 4 be? Well, pi over 4 is 45 degrees. So if I looked here, it would tell me 1 over root 2. So that means the value will be 1 over root 2. The last piece of information I need to check is, will it be positive or negative in quadrant 2? It's positive, so we leave it as it is. It's going to be 1 over root 2. Okay. Similarly, if I go to the cosine of 45 degrees, back up to my triangle. Cosine again here is going to be 1 over root 2. Sorry, that would be the sine, but it does work out. It would be 1 over root 2, adjacent and hypotenuse. So it is 1 over root 2. Should it be positive or negative in quadrant 2? Should be negative. Okay, so see if you can finish off the rest of this chart and try it for negative 7 pi over 3. Okay, so I'll try to catch up to you here so you can double check your answers. So all I did for these three was I just took the reciprocal of their corresponding ratio. So instead of 1 over root 2, I just flipped it. It becomes root 2. So for the next angle, 7 pi over 3, if you do the quick thinking of it, that's going to be 6 pi over 3 is 2 of them. And then because it's negative, I'm going to be backing up by 1/3. So if I back up by 1/3, I'll be down here somewhere in quadrant 4. Okay. The reference angle for this will be pi over 3. It is the amount that's left over from here to here. And I can use pi over 3 now, which is 60 degrees. So I'm looking at this angle. For the sine, it's going to be root 3 over 2. For the cosine, it's going to be 1 over 2. For the tangent, it's going to be root 3. Now, I have to apply the cast rule in quadrant 4. So in quadrant 4, the sine is negative, the cosine is positive, the tangent is negative. So these are the exact values. Their reciprocals look like this. And that would be the remaining exact values. Any questions so far? It's okay. So let me just see if 5 is the worst thing ever. This is like logs times 10. Show me a 5. If you're with it and you think we can move on, it's okay. It's something like a 1 or a 2 should be on your hand. I just see quickly here where we're at. Is that the cool way to do it? Okay.